Okay, YouTube, in our last video, we looked at a new definition of the three proper trig functions, which are sine, cosine, and tangent, just by knowing some point on the terminal side, saying that we could form a right triangle with this and determine, say, the 6 trig ratios of that angle just by knowing that terminal point side, or terminal side point. So that being said, what we're going to look at in this video are what we refer to as quadrantal angles. And that is to say that angles that don't terminate in any given quadrant, they terminate on an axis. So these would be angles like 0 degrees, 90 degrees, 180 degrees, and 270 degrees. In this video, what I want to do is kind of confront what would it be like if we were to try to find, say, the cosine or, say, the cosecant function value of these angles, theta here. And so what I'm going to do is in each of these instances, I'm going to kind of sketch a picture of what we have here. So our 0 degree angle, our 90 degree angle, our 180, and our 270. We could also see these in radians: 0, pi halves, 2 pi halves, which is pi, and 3 pi halves. Let's go ahead and sketch these. So for our 0 degree angle or 0 radian angle, we have this. Our 90 degree angle, of course, in standard position, we would have left from the positive x-axis. We would have said that this is 90 degrees here. 180, this will be our straight angle here. We'll go ahead and label this. We have 180 degrees, and then 270 degrees, or 3 pi halves. This would be this angle right here, 3 pi halves. And so with respect to these situations, what I'm going to tell you is that we're just going to choose any point on the terminal side. Now, some interesting things happen with these four angles here. I've highlighted a point on each of their terminal sides, but the thing here is that we can choose any point on the terminal side. So if I'm going to choose any point on the terminal side of this angle that I've drawn a picture of right here, I would assume that I'm just going to choose 1, 0, which I could use 2, 0, 3, 0, a million, 0, but it would have to have a y value of 0 and some x value here. Likewise, over here, I would choose the point 0, 1. For a 180 degree angle, I would choose the point -1, 0, and for a 3 pi halves radian measurement, or a 270 degree angle, I would choose a 0 x value and a -1 y value. So these are going to be our points on each of these. The interesting thing happens when we start to look at this using this new definition of the trig functions. Now we know our x and y values, or at least for the 0 degree case or 0 radian case, we have an x value of 1 and a y value of 0. Now, the only thing we aren't yet aware of, which is this r value here. We're used to having some angle in standard position, where there's a point here and we could form a right triangle with it. But what happens when your right triangle kind of, you could imagine it looking like this. We would say that this is 1, and that this is 0. Crazy idea, okay? But what we're going to see here is this. We would say that this r value, since this is the point 1, 0, and r is the definition of r, is the distance from this point back to the origin, we could clearly say that this distance here would just have to be 1. Now, one thing that I want to mention is that we can certainly do what always works, which is the square root of x squared plus y squared. Let's go ahead and do this here. We would get the square root of 0 plus 1, which is the square root of 1, and we just get 1. So with an r value like 1, I'll go ahead and list this over here. R value like 1, x value of 1, and a y value of 0. Let's go ahead and find the cosine of our angle here. And cosine being x over r. Remember, this is x over r. Let's go ahead and take our x value, 1, put it over r value, 1. And what we find out is the cosine of our angle here, which, by the way, I need to scratch this out and put cosine of 0 degrees is equal to 1. Now, for the cosecant of 0 degrees. The interesting thing here is that we're going to start by finding the sine of 0 degrees first and then reciprocating it. So the sine of 0 degrees would be y over r. Our y value is 0, our r value is 1, so we get 0 divided by 1, which is 0. So we'd say that the cosecant of this angle is the reciprocal of this. It's 1 over 0, which actually comes out to be undefined. So one interesting thing about sine and cosine is that since the r value is always positive, and x and y is some point on the terminal side, it's never 0 and 0, we'd say that sine and cosine are always defined. But what you're going to see here is that because we, with cosecant and secant, sometimes divide by x or y, then what we're going to get are undefined trig functions at certain angles. Let's go ahead and finish these out here. We say 90 degrees. What would this look like here? Well, we have an x value of 0, a y value of 1, and this was just a result of we chose to choose that point. Now our r value here would be the square root of 0 squared plus 1 squared, which does come out to be 1 again in this case. But we could clearly see this from the picture up here. This distance back to the origin from 0, 1 is a distance of 1. So using these three here, let's go ahead and do the cosine of 90 degrees, and we want to do the cosecant of 90 degrees. But let's start with the cosine of 90 degrees. We have x over r. Our r value is 1 and our x value is 0. So the cosine of 90 is 0. We say the cosecant of 90, well, the sine of 90, remember that the sine of 90 would be y over r. So our y value here is 1. Our r value is 1. We get 1. So the cosecant would be its reciprocal, which is also just 1. So we have our two values here. Let's go ahead and deviate over to 180 degrees here. We see that we have an x value and a y value of -1 and 0 respectively. So our r value, we would settle upon a 1 here, which would be the same thing as the square root of 0 squared plus -1 squared. But that being said, let's go ahead and find the cosine of 180 degrees. We'll find the cosecant of 180 degrees. Start with your cosine. Cosine is x over r with an r value like 1 and an x value like -1. We actually get a -1 in this case for our cosine value of 180. And then down here at 180 we say, what's cosecant? Well, what's the sine of 180? I mean, what's our y over r value? And our y over r value, our y is 0, our r is 1, so we get 0. So our cosecant at 180 is going to be 1 over 0, which gives us an undefined value. It's very important we know that sometimes trig functions come out to be undefined. And so lastly we say at 3 pi halves. Why don't we do this one not in degrees, but we'll put it in radians. We say cosine of 270, which is cosine 3 pi halves, and then we want cosecant also of 270 degrees, which is 3 pi halves radians. So the cosine here is x over r. We say our x value down here is 0. Our r value, well, clearly it looks like 1, but we could check that out algebraically. We get 0. So the cosine of 270 is 0. We say, what's the cosecant of 3 pi halves? Well, we're going to need to know the sine of 3 pi halves in the first place. And given that the sine is y over r, we're going to have a y value of -1 over an r value of 1, so -1. So what we end up with here is 1 over -1, which is also -1. So in terms of quadrantal angles, here's the rule. Just go ahead and pick any point on the terminal side. You should be able to work out the sine, cosine, and or tangent of any of those just by knowing some point on the terminal side and the value of r. Cheers.